Good morning, students. In the last class, we discussed about the polarization, that is, the light wave is transverse in nature. We proved that the light waves is transverse wave by using the polarization. So today we start the topic polarization by reflection. Polarization by reflection. So we already know. So what is reflection? We studied the reflection in ray optics and also in this chapter only in wave optics. So what is reflection? When a light ray falls or a light beam of light which falls onto the surface which separates the two medium, some part of the light will bounce back to the same medium. So that phenomenon we call as the reflection. So here also in polarization also the same process will happen. That is, when an unpolarized light will falls onto the surface which separates the two transparent medium, then some part of it is reflected and some part of it is refracted. So that process is the polarization by reflection. That is, we get the reflected light, that is reflected light is polarized. That is, the vibrations of the particle in the reflected ray is vibrating in one plane. So that phenomenon is the polarization by reflection. So here, so this one is the surface, right, which separates two mediums. So this one is the medium 1. Above the surface we consider as medium 1 and below the surface we are considering as medium 2. So this medium has the refractive index. We call that one as N. So N is the refractive index of the medium 2. When an unpolarized light which falls onto the surface, right? So this is the unpolarized light which falls onto the surface. Then some part of it is refracted into the second medium and some part of it is reflected, right? So if we indicate the unpolarized light, that is arrow marks with the dot in the center, it represents the unpolarized light, right? When an unpolarized light, so this one is the unpolarized light. When an unpolarized light strikes the surface which separates the two medium, medium 1 and medium 2, which have the refractive index, that is N, then some part of the light is bounced back to the same medium, then this phenomenon we call as the reflection, and some part is transmitted to the second medium, and here this phenomenon we call as refraction. So this light is the incident light. So incident light is the unpolarized light. This one is the incident light. So here the light which bounces back to the same medium we call as reflected light. So this one is the reflected light or reflected electric vector, that is light vector. Here we are studying the polarization, hence we get the reflected light, that is electric vector, and here we get the light is refracted light. Refracted light, right? So here this one is the normal, the angle which makes the incident ray light which makes the angle with the normal, that angle we call as angle of incidence, and the refracted ray makes the angle with the normal, that angle we call as angle of refraction, that one we taken as R, right? So here already told that in the reflected light we need only the vibrations of the light particles that are in vibrating in only one plane. For that one we are considering this incident light into two components. So we are considering the incident light into two components. So in that first component, we are considering here the particles are vibrating in all the directions. That is here. That is why this one is called as unpolarized light. So here considering the components, this unpolarized light is considered into two components. In that first component is the component perpendicular to plane of incidence. So this incident light is resolved into two components. In that first component, we are considering perpendicular to the plane of incidence, that is dot one. Right? Here we have the dots and also we have the arrow marks. So the dots are perpendicular to the plane of the incident. This one is the first component, and the second component is the component in the plane of incidence, that is arrows, right? So this unpolarized light, that is unpolarized light, is denoted by the arrow mark with dot in the middle. So this one is divided into two components. So one is the arrow mark and another one is the dot. So dot represents what? The dot represents, this one is perpendicular to the direction of the incidence, and arrow mark represents in the direction of the incident. So this one is the incident, right? So these components are in the direction of the incident, that is parallel to that of the incidence. We are considering into two components. So the first component is perpendicular to the plane of incidence, and the second one is the component in the plane of incidence, that is the components which are parallel to the plane of incidence, right? So next, so if we study the first one, this component, the component which are perpendicular to the plane of incidence is always parallel to the refracted surface. So these dot components are always parallel to that of the surface, right? So these components that are dot components are always parallel to the surface which separates the two medium, right? Because these are vibrating in inside into the board. So these are always parallel to that of the refracting surface. Hence the percentage of the components, that is dot components, are same in the refracted light. So here we get the dots, right? For any angle of the incident. So either it may be 10 degree, 20, 30 or 60 degree. For any angle of the incidence, the dots, that is here we are taken the components which are perpendicular to the plane of incidence is always parallel to the surface. Hence the components are same, that is some percentage, that is it is some part is reflected and some part is refracted. Hence some part is same in the refracted light. So here we are studying the dots, hence we get the dots in the refracted light for any angle of the incidence, right? So I understand this one. This unpolarized light is divided into two components. So for the first component, that is perpendicular to the plane of incidence, that one we call as dots. So that dots are always parallel to that of the refracting surface. Hence the percentage of the components will be same in the refracted light, that is some percentage of the incident dots are on the same on that of the refracted light for any angle of the incidence. So this will be constant. So for any angle of incidence, we get the dots on the refracted light. So this one is the first, right? Similarly, the component in the plane of the incidence, that is the arrow marks. So here is the dot, right? So these are the arrow marks which are present in the unpolarized light. So these are always, so these are in the plane of incidence, right? These makes angle, different angles with the surface for different angle of incidence, right? So understanding these vibrating particles, that is these vibrating lights or electric vector makes different angles with the surface for different angle of incidence. Are you understanding? So here what happens, the components, that is arrow mark, the components in the plane of incidence is makes different angles with the surface for different angle of incidence, right? So these arrow marks makes different angles with the surface for different angle of incidence. Hence, the percentage of the components. So the percentage of the components which are refracted, which are on the refracted light, is depends on the angle of incidence. So understanding this one, the percentage of the components which are on the reflected light is based on the angle of incidence. That depends on the angle of incidence, because these makes different angles with the surfaces for different angle of incidence. Hence the components on the, hence the components on the reflected light, hence the components on the reflected light makes or depends on the reflected light, depends on the angle of incidence. So this one is the important, right? So here we are getting the arrow marks. So these arrow marks depends on the angle of incidence. If the angle of incidence varies, then here we are getting the component of the, that is components which are in the plane of the incidence will vary. Hence the reflected light we get here may be unpolarized or partially polarized or completely polarized, right? So this, the components, that is the components in the plane of incidence, these arrow marks depends on the angle of incidence. So for the vary of the angle of incidence, then the reflected light may be unpolarized or maybe partially polarized or maybe fully polarized. So here we are studying for the polarization by reflection. Hence we need this reflected ray as fully polarized, right? For completely polarized, we need this angle of incidence. For any one angle of incidence, this may be fully polarized. For particular angle of incidence, this reflected light is fully polarized. So that angle we call as polarizing angle or Brewster's angle, right? For particular angle of incidence, for a particular angle of incidence, the reflected light is completely polarized. So that angle we call as polarizing angle or Brewster's angle. For a particular angle of incidence, for a particular angle of incidence, the reflected light is completely polarized. So that angle we call as polarizing angle. That is polarizing angle, or we call that one as Bristol's angle. So it is denoted by IB, right? So if we have here IB, that is polarizing angle, then what happens? The component in the plane of incidence, that is the 100%, the components which are in the plane of incidence are completely refracted, right? So the components which are present in the unpolarized light, that is the arrow marks, which are 100% or refracted. So then here what we get is, these are the second components, right? We get like this. So 100% the components are refracted. That is 100% the components are refracted. Hence we get, so here we have 100 arrow marks, means here also we getting the 100 arrow marks in the refracted ray. So here we have some part of the light is reflected and some part of the light is refracted. Then the first component, that is the component perpendicular to the plane of incidence, only will be in the reflected light, like this. So now if you observe here, then here the light, the reflected light is completely polarized, and the vibrating, the electric vector which are vibrating in the plane of, that is perpendicular to the plane of incidence. Hence we get the reflected light is completely polarized, right? For a particular angle, that is for the Bristol's angle, the incident component, that is in the plane of incidence, is completely refracted, and hence we get the reflected light is completely polarized. Here the vibrating particles are, here the electric vector vibrating or oscillating perpendicular to the direction of incidence. That is, these are vibrating only in one plane. Hence we get the reflected light is completely polarized, right? So this is about the polarization by reflection. So what happens in polarization by reflection? As we studied earlier, that is reflection, when a light or a beam of light which incidents on the surface, which separates the two transparent media, some part is reflected and some part is refracted, right? Here we are studying polarization. So unpolarized light which falls onto the surface, so some part is get refracted and some part is reflected. For study the polarization in reflected light, we consider this unpolarized light into two components. So one component is component which is perpendicular to the plane of incidence, so that one is the dot, and second one is the component in the plane of incidence, that is arrow mark. Here the component which are perpendicular to the plane of incidence is always parallel to the refracting surface. Hence the components, few percentage of the components are get refracted for any angle of incidence. That will be remain same for any angle of the incidence, right? Next, the component in the plane of incidence, that is arrow mark. So these are makes different angle with the surface for different angle of incidence. So these will make different angle with this surface for different angle of incidence. For that reason, in the reflected light, these components depends on the angle of incidence, right? So hence for that reason, the reflected light may get the unpolarized light, maybe partially polarized, maybe completely polarized. We need completely polarized light. Then for a particular angle of incidence, for this particular angle of incidence, these components which are in the plane of incidence, that is these arrow marks, are completely refracted. Hence, we get the dots only in the reflected light. Hence, this shows that the reflected light is completely polarized, and also these are vibrating perpendicular to the plane of incidence. Hence, here we get this reflected light is completely polarized, right? So understand this one. So here simple is we divide this one into two components. One is dots and another one is arrow marks. So dots, some part is reflected and these dots are some in reflected and some in refracted. So if you observe here, we have dots here and also here, right? So here we have again this one we call as unpolarized light, because these are with two vibrations in two planes, that is dots and also arrow marks, right? So for this one, this reflected light is completely polarized. So for getting this completely polarized light, that angle is called as Brister's angle or angle polarizing angle. So this is important for 1 marks, that is what is polarizing angle or Brister's angle. And next is, from this we can prove that the Brister's law. So understand this one, it is a simple concept. The incident unpolarized light is divided into two components, and further we study this component, what it happens when the light will falls onto the surface, and what about this component, right? So next is, so same these components we will study in the polarization by scattering. There also we divide the unpolarized light into two components, that is which is parallel to the plane of incidence, or that is in the plane of incidence and also perpendicular to the plane of incidence. So from laws of reflection, this is the normal. The angle of incidence is always equals to the angle of reflection. Then the angle of reflection can also be written as IB. So the angle between the reflected light and to the refracted light is always equals to 90 degrees. Right? From Snell's law, so we can write the refractive index N is equals to sine of the angle of incidence to the sine of the angle of refraction. So this is the Snell's law, right? So here the angle of incidence is what? That is IB, sine IB. Next, this one is the angle of refraction. So here we are studying the reflection. So the angle of refraction can transform into angle of reflection. So if we observe here, this one is the normal line, right? So this is the reflected light and this one is the refracted. So angle between these two is 90 degree. That is angle between the reflected and refracted is 90 degree. This one is the angle of refraction and here is the angle of reflection, because angle of incidence is equals to angle of reflection, hence IB. So this one is 180 degree. So if we write here IB plus 90 plus R, that is equals to 180 degree. So here we need R. Then if we shift 90 to the RHS, 180 minus 90, we get 90 plus IB. If we shift to the RHS, then it becomes minus IB. So now we replace the angle of refraction in terms of angle of reflection, right? So if you substitute here sine of, in place of r we can write this one as 90 minus ib, right? So from trigonometric function, sine of 90 minus ib can be written as cos ib. That is, sine of 90 minus theta can be written as cos theta. So keeping numerator as it is, sine ib divided by sine of 90 minus ib can be written as cos ib. So in the LHS we have the refractive index n. So sine ib divided by cos ib can be written as n is equals to tan ib. So this one we call as Brewster's law. So this one is very important for 3 marks or 2 marks. So what is Brewster's law? The refractive index of the medium is equals to the tan of the angle, that is polarizing angle or Brewster's angle. So this is the statement of the Brewster's law. So what is Brewster's law? The refractive index. So n represents what? Refractive index, right? So the refractive index of the medium is equals to the tan of the angle between, that is tan of the angle of polarizing angle or Brewster's angle. That one is the statement of the Brewster's law, right? So when we get completely polarized and when we get unpolarized light, here means when at the angle of incidence I is equals to 0 degree and 90 degree. So here we get when angle of incidence I is equals to in the angle of reflection, when I is equals to 0 degree and 90 degree. For angle of incidence I is equals to 0 degree and 90 degree, then we get unpolarized light. For the angle of incidence I between 0 and 90 degree, for the angle of incidence between 0 degree and 90 degree, we get partially polarized light, right? So this is about the polarization by reflection. So this polarization of reflections depends on the angle of incidence. We have to remember this one. That depends on the angle of incidence, and for a particular angle of incidence we call as Brewster's angle. That is IB we call as Brewster's angle. Here IB called as Brewster's angle or polarizing angle, right? So this is about the polarization by reflection. So this proves here the reflected light, the electric vectors which are vibrating only in one plane, that is perpendicular to the plane of incidence, right? So this completes the polarization by reflection. So in this the main important is Brewster's law, that is the proof for the Brewster's law by using Snell's law. As we studied in the ray optics, n is equals to sin I divided by sin r. So this gives the Snell's law. Refractive index of the medium is equals to sin of the angle of incidence to the sin of angle of refraction. Now we replace the angle of refraction in terms of angle of reflection. So here the angle of reflection is 90 minus IB. So sin of 90 minus IB can be written as cos IB. Hence the refractive index n is equals to tan IB. The refractive index of the medium is equals to tan of polarizing angle, tangent of the polarizing angle or Brister's angle. So this is the statement of the Brister's law, right? So next concept is polarization by scattering. Polarization by scattering. So what is scattering? Already we studied the scattering in ray optics, right? So what is scattering means? That is when a ray of light, that is the sun rays which falls, that is that travels in a homogeneous medium, then the light rays are scattered, that it changes its direction, then that one we call as scattering. So here also same thing happens. So here what happens when an unpolarized light from the sun, so this if we consider as sun, so from here this is unpolarized light, right? So the light which are coming from the sun, that is unpolarized light. Here also we can resolve this unpolarized light into two components. One is parallel to the direction of incidence, that is nothing but the arrow marks, and also the dots which are perpendicular to the direction of the incidence, right? These are the two components. When the sunlight falls onto the, that is it travels in the earth atmosphere, when it strikes the molecules in the earth atmosphere. If we consider this one is the molecule in the earth's atmosphere. So molecules consist of atoms and atoms consist of electrons, right? So when an unpolarized light which travels in the Earth's atmosphere, it strikes the molecules which are present in the Earth atmosphere. Hence the atoms which are present in these molecules acquires these two components, right? So here we have the electrons in the molecules. So these electrons, here the unpolarized light nothing but the electric vector E, that is light vector. So these two components are acquired by the electrons, right? So these electrons acquires the unpolarized light, that is the electric vector. This one is the electric vector. Now considering the observer is 90 degrees to the sun. So here is the observer. So if you observe, the sun is 90 degree with the observer. So this one is the perpendicular, means the observer is 90 degree to the sun. So electrons which acquires this electric light vector, then the components, so the components which are in the direction of the incidence accelerates parallel, right? So here these components acquired by the electrons means accelerates parallel to plane of parallel to plane of incidence, right? So these are the vibrations which are parallel to the plane of incidence. So these vibrations are acquired by these electrons and hence it accelerates in the parallel direction. Hence it will not radiate. Hence it will not radiate energy to the observer. For this reason, the components which are parallel, that is components which are in the direction of incidence acquired by the electrons, then it accelerates. The charges which are present in the molecules are get accelerates in the parallel to the direction of incidence. Hence these radiations, that is these vibrations will not radiate energy to the observer because these are parallel. So here the electrons acquires the electric vector and it radiates and it accelerates in the parallel to the incidence. So if you observe here, so these are the vibrations which are parallel to that of the incidence. Hence these are not radiates energy to the observer. Hence the light get scattered. Hence the light gets scattered and in the direction to the observer, that is denoted by dots. So this shows that scattering. This shows that the scattering of sunlight. Right? So this is also the simple phenomena. So these are perpendicular to the plane of incidence. So dot represents the vibrations which are perpendicular to the plane of incidence. So these are the vibrations which are parallel to the plane of incidence. Right? So this is about the polarization by scattering. That is unpolarized light which are coming from the sun enters the earth's surface, it strikes the molecules which are present in the earth's atmosphere. Then here we, for the study of scattering, this unpolarized light is divided into two components. So one component is parallel to the plane of incidence, that is arrow marks, and another component is perpendicular to the plane of incidence. Right? The electrons or charges which are present in these molecules acquires the electric vector and it gets accelerates parallel to the plane of incidence. Hence, it will not radiate energy to the observer, considering observer is perpendicular to that of the sun. Right? So this one is the sun. Hence, we get the vibrations which are perpendicular to the plane of incidence to the observer. So this shows that scattering of the light takes place when it strikes the molecules which are present in Earth's atmosphere. Right? So this is about the polarization by scattering. So by this, we completed the chapter wave optics. So in wave optics, we studied Huygens principle. So by using Huygens principle, we studied reflection and refraction. Then we studied the principle of superposition. By using the principle of superposition, we discussed interference, and interference, we have one experiment, that is Young's double slit experiment. From that we derive the derivation for the fringe width. Next, we studied the diffraction and polarization. So in polarization, that is by reflection and by scattering. So we have to more concentrate on the topic, that is interference for 5 marks, and for 3 marks, that is diffraction and polarization, and also resolving power of optical instrument. Right? So 5 marks, very important derivation we have, that is fringe width beta. We have to practice this one, the fringe width. They ask several times for 5 marks. Otherwise, if they don't ask the derivation, means compulsory they will ask for the 5 marks numerical. That is from the topic interference. That is also based on the fringe width. For 3 marks, they ask the diffraction. For 2 marks, we have important concept in diffraction is path length. That is when is maximum and conditions for maxima, condition for minima, and also the difference between interference and diffraction. So in polarization, they ask the Brister's law. That is proof, state the Brister's law and proof for the Brister's law for 3 marks. And also they ask for the resolving power of the optical instrument in 1 marks. That is the formulas they will ask for the resolving power of the optical instrument. So by this we completed this chapter, that is wave optics. So this chapter is also for 9 marks. So ray optics is also for 9 marks and also wave optics is also for 9 marks. So these are the two main chapters in the second part. That is, in second part, these are the two main chapters that will come around 18 marks. Right? So in the next class, we will start with the new chapter. Thank you.